Very good morning, everyone. Am I audible? Okay. I think Aarti has already asked a question like, how many of you have already shipped or built an AI agent, right? I couldn't see the hands. Can you please raise your hands? Well, so is it really working for the client's real use cases in production? Yes. Half big? Okay. Not in the large scale, okay? Fine. So my talk is going to be around what it takes to productionize at a scale the AI agents. There are so many things that is happening around us. Like you may have seen last week, Anthropic has released a new product called Dreaming. Have anyone heard about Dreaming? What it does? Intentionally or unintentionally, we ingest some data from some systems which we are not aware of, right? So the role of Dreaming as a product is to analyze our past prompts and responses and look at what intentionally or unintentionally we made a mistake and correct it. So the role of Dreaming is evolving since last 2 weeks, and to make it better, they're again training, and it's a deep agent. What's a deep agent? Agent versus deep agent. So deep agent is something which looks at various things, your past session history, knowledge graphs, your databases, your API calls, your external systems, your context window, everything. And also it looks at your prompts to suggest you what is good for you. So we are in a situation today, like if you look at 73% of the enterprises where they're running the AI pilots, they are not making it to production. You will hear that, okay, we have a very interesting demo. We have a very good demo, but it's a demo. It doesn't work in the real life scenario. It doesn't solve the customer's real problems. So what it takes to build the real agentic AI systems. So now if you look at the agentic paradigm here, the sales team, what they sold versus what actually get shipped. The sales team, they look at, okay, you have very good demo agents. Now, I can show you in 5 minutes doing crazy stuff. But when we practically put it into production, the first major issue is latency. Oh, it's a demo issue, so we can fix it, we can correct it, etc., right? So scale is something which you have to handle first. First, you have to look the latency part of it. It's the agent is in process. Maybe you have seen a lot of demos around agentic. You can see the chatbot, you ask a question, it is still running. It's in process, right? So that is the real issue. Now, are you going to blame the APIs, the LLM providers, the agentic system that you have built, the orchestrator that you have put? Which ones to blame, right? So the question here is, how do we design the system for enterprise? The first thing is we have to recognize the organizations have fragmented systems. They don't talk to each other. So many databases, like you have MongoDB, you have PostgreSQL, you have SQL databases, you have signups databases, so many databases around it. Different clients, they also have different databases. When you are building the agents and the agents are talking to databases to fetch relevant information to answer your questions, one database becomes unresponsive. Now, what happens then? What's the fallback? Is it going to search in another database? Is it going to stop the agent working altogether? That I couldn't find the relevant information, I can't answer your question. What's the fallback design for this, right? So first issue is fragmented systems. The AI is not going to work on fragmented systems. You have to consolidate all your systems together in such a way that the agent can have access to it, right? The second part is the domain constraint. What is domain constraint? Basically the GRC, governance, risk, and compliance. You are looking for a particular tool, your GRC team is not approving it. Your agents need that particular tool to perform some action, but you are not able to get that. There are certain tools, like I will not take the names of some LLMs that is being banned in various organizations. Like few models, like you can take DeepSeek, you can take Quinn,
It's not allowed. Now, if there is a very specific task, you are dependent on, let's take Quen or DeepSeek, you are not able to use. So GRC and the domain constraint is one of the issues that we have to be cognizant about. Look at the long horizon workflows. What is long horizon workflow? When your workflow goes through various loops. Long horizon means final output is relevant, but intermediate steps are many. How do you cover those things? And this is where most of the agents fail because we don't have a fallback option. We give a command, we are expecting the response, and we are not getting that response. There is no fallback system, right? So these are some of the issues. And also finally, the graceful recovery, or if it is failing, what to do next. Fallback is one of the options. So shall I go ahead and search for additional information and correct it? Or I'll say that I don't know. So the entire anatomy of the AI agent in an enterprise world have those 6 layers. Those 6 layers are they're going to work with the LLMs as the agentic core or the reasoning core. The first one is the tooling layer. The tools are, it could be simple like calculators, the weather applications, it could be geomap. So these are some of the tools. Now, tools are something the agents would need to perform various actions. Okay. Now, how do you provide those tools access? Some of the tools which is free, you can simply install, like for example, Tavily or DuckDuckGo. So these are some of the search engines we can easily integrate. Are they good? No. Are they exhaustive enough? They can provide a lot of context to your agents? Probably no. But there are certain tools like, let's take, you are looking for Google search or Bing search. You need APIs, right? So the tooling layer, how you are designing the tooling layer, that is important. And that's where the MCP is going to help you. The MCP server will help you instead of every time authenticating a request from the agent to the tooling layer, you introduce the MCP layer. So without authentication, it can have handshake always with those tools. That's the first layer that you have to solve for. The second one is the memory layer. So there are 2 kinds of memory. You have session memory, you have the persistent memory. The persistent memory can be stored in vector databases, and persistent memory can be stored in your knowledge bases or knowledge graphs. Why there is a difference? Because as you incrementally gather more and more amounts of data from various sources, you keep building those vector databases, the number of embeddings will go up. It will continue to increase. And there is a point it is going to fail. So your vector database is going to crash. Now, the way to proceed is that how do we process the unstructured information in such a way that we can store the information in knowledge graphs. So knowledge graph is the most compressed form of storing unstructured data so that your agents can get the context. That's part of your memory system. The third one is the evaluations or the AI agentic harness. Evaluation systems, you can have LLM as judge to evaluate certain things. You can have multiple judges also to evaluate the outcomes. And the guardrails, I will call it as a plural, guardrails. One single guardrail is not enough. You need to have multiple guardrails at different stages. The first stage is the input stage itself. You should not contaminate the thinking process of LLM by providing vague prompts or irrelevant prompts. So the goal of a first guardrail is to restrict the irrelevant prompts. Okay. Now, observability is one of the important thing for agentic monitoring as well. How the agents are behaving and which agents are calling the other agents. What happens if there is a failure? So those observability, we have ML ops observability. We have LLM ops observability. Today, we do not have agent observability tools in the market. And that's probably some of the companies they will come up with in next couple of months probably. But today it is not there. So if it's not there, then how do you do? You have some observability tools. Can I extend these tools and have a log and monitor it? Right? So you have to design this system. It is not existing. And in enterprises, the ML observability tools are there. The model observability tools are there. The infrastructure observability tools are there. With existing tools, you have to use, right? And finally, human in the loop. human in the loop approval process is very important. If there is a critical decision that the agent is making, you have to make sure that you have the approval of some human beings. When you send for approval, you have to make sure the human being is observing, monitoring, and seeing the system. Otherwise, you will not take it, right? So the agent will be in infinite loop thinking that the human will approve it. And after 30 seconds or after 1 minute, it will just kill the system. So you have to constantly monitor the screen to approve it, right? So if a human being is always required to sit in front of a system to approve the agent's actions, then again, there is a human dependency, right? So how do you design that system? Are you going to send a notification on WhatsApp that, hey, there is a decision needed on this agentic process, can you approve it? Or a Jira ticket or something else, right? That's not there today. So you have to design that system, okay? So the entire agentic operations in an organization at enterprise level, it involves multiple steps. So the first step is plan. So planning is like, it can be a single step plan or multi-step plan. But planning is writing down your entire workflow. Step 1, I'm going to do this. Step 2, I'm going to do this. Step 3, I'll be looking for this information in this database. Step 5, I'm looking for this tool, right? So entire workflow you have to write, and then you have to think, am I supposed to use LLM or not? Can I handle this using any other tool or a programming language or maybe a Python library? That you have to think. So planning is all about how to orchestrate the entire solution, the agentic operations. The second important part is the selection of right tools. So as I said, like there are multiple tools. Search engines, there are 20 search engines. Like APIs to connect to databases, there are 20 different databases, right? So which one to use, when not to use. And how do you know this? Quick prototype, right? So quick prototype or R&D is important to understand the response time. So let's say you have a big data, like terabytes of data stored in database. And you have one agent which will be looking at the database and answer the questions. Definitely latency would be there. Because your PySpark cluster, spinning up the cluster and just setting it up, it takes 2 to 3 minutes, right? So how do you design the system? Shall I make a call beforehand just to make the session ready and infrastructure ready before sending the agent request? So before that, I need another agent which will make the system or environment up and running, right? So selection of right tools and again validation, which is there are different databases, different schema. Schema structure is not consistent. And you have to first have one agent to see the schema, design the SQL syntax or any other query syntax. You have to redesign it, right? Because as a human being, you have to see the data to take these decisions. If you are replacing the human being with agent, the agent has to see the schema and design the SQL, right? Because without that, it's not going to proceed to the next step. Then the execution layer. The execution layer is where it breaks. You have connected 5 MCP servers, 2 of them are unresponsive. What to do? Are you going to go ahead with all 3 MCP servers or you kill the process there and exit out of the loop, right? That decision you have to take beforehand. Because if you kill the process and exit out of the loop, your agent is not going to produce the final output. Is it acceptable to you or not? Right? And by design, the tools and MCP calls are going to fail. And that's the reality in production. They are going to fail. Definitely they're going to fail. They may work 95% times or 100% of the times on your demo instances. But in production, they're going to fail. Definitely. So you need to plan how to design this. Okay. And the final thing is observe and reflect or feedback. The next thing about the architectural decisions that matters. So as we have already briefly covered, so we have to design the tools, not the prompts. Prompt is also important, but tooling is very important. There are so many tools, as I said, right? You may think about, okay, I can just upload a document. I can start asking questions, but how the LLM works in the backend, right? So that process is, we call it RAG, right?
You have a document, you want to ask questions, you just upload the document and you start asking questions. But what happens when you upload the document? When you upload the document, there is a parser engine. The parser first scrapes the text from the document, prepares the chunks, creates embeddings. Those embeddings are ingested in a virtual Chroma DB or any other vector DB. And then when you ask a question, it goes and finds the embeddings, the relevant embeddings, and then it starts writing the answers. If you have submitted a document having a screenshot, it's not text, right? The LLM knows that I have to call a visual model to get the OCR done and extract the text, right? If you have a complex document which has text, tables, images, and audio and video, right? If some of the LLMs are working fine, but some other LLMs, they don't work in such scenarios. So you need a tool here which can act like a universal parser. Any kind of document, it should be able to parse the content and create these embeddings so that it can answer your questions. Now, if you rely on the open, or let's say, on the open LLMs or enterprise LLMs, some of them they work, some of them they don't work. This is one example. The other example is like if you have multiple pages on the website, like multiple traversals has to happen to extract the text, right? You have to click on page 1, then page 3, then page 7, like that, right? If you give the post landing URL to the parsers or the any other open models or like LLMs, they'll scrape the text from the first page itself. They will not go to the second, third, fourth, all the subsequent pages. So you need a separate tool that would help you to go to the nth depth of the pages to extract all the text, right? Otherwise, you have to do manually. You have to click on all pages, collect all those URLs, give this entire URL list to the LLMs to scrape the text, right? So tooling is very important, and designing the tooling is a skill. The next important point is making the planning observable. That means first you have a structured steps. You have to write down the steps. Okay, I will first have a look at, let's take my database. Second, I have to fetch information from this API. Third, I have to summarize this information and that information. Fifth, I have to take a decision whether to proceed or not, right? One is the handoff between multiple systems, like your LLM system, your tools, your databases, and the decision. And drafting the final response for the user. So there are multiple handoffs are happening here. That is why it's very important to have the observability here so that it can understand and remember the intermediate states and it tries to solve it for you. Third one is separate memory from the context. Context is different, memory is different. That's why I gave you the example of a dreaming from Anthropic. They separate the context from the memory. Everything that we dump into the LLMs today, we think that this is context and this should be a memory that the LLM should remember, right? So we can easily fill the context window, right? So everything that we dump, it is not memory, remember. So throughout the day, you may have, you have different access to different LLMs. You may have tried, right? Morning, you are putting some document asking a question. Evening, you are putting some document asking a question. Is it memory? No, this is context. This is not memory. So the job of dreaming is to separate the noise from it, construct memory, and store the memory for future uses. Similarly, when you are building the agents at enterprise level, you have to separate the noise from the context and build the memory. How to build the memory? The memory should be built as markdown files, and you can store it as skills. For example, in Anthropic. Similar kind of skills, you can export it and use it in OpenAI as well. Okay. The fourth one is the harness or the evaluations. When the agent goes wrong or produces something unacceptable, then you have to look at how to control it. And finally, the graceful exit. So what it takes to scale at an enterprise level, if we look at today, most of the agents, they work in prototype or demo, but they fail
when you put it into production. That's why you have to take care of a lot of things. The first important thing is about latency. Second important thing, cost, right? Cost per tokens. So let's say you are building something and you have reached the max tokens. So you have two options. Either you wait for the next window or you pay and go, right? So how do you reduce your token usage? Because you have to be very careful about what documents you are putting in LLMs or in agentic operations. If you have a 200-page PDF and you think that this is useful, and you simply upload those 200-page PDF to the LLM and you want the LLM to process it, but actually the information that you're looking for is in chapter 5 or page number 23. So why to upload the entire PDF? These are small things that makes huge difference. Now, if you have something that your agent needs access to the logs, you are sending the full logs to the LLM. But why? The event actually happened in last week. So I have to send the last week's log only. So how do you filter the information that the agent needs versus pulling the entire information and dumping it to LLM, right? So these are small nuances which takes like conscious effort from your side to make it happen. But these are the issues in production scenarios. The third important is the edge cases. How do we test? So any software application we are building, we have unit test cases, we have regression test cases to test out the application before making it to the production, right? But how do we test the agents? Few sample questions, we test it and we are ready to go, 100% accuracy? No, right? We need real users. And that's where you have to implement and roll it out to a couple of users and take the feedback. How it is working, whether it is good or bad. Take the feedback, introduce the feedback as additional instructions to the agentic process itself, right? And don't say that it is 100% perfect and it's going to work. Tell them that I need 90 days or 6 months to make it work. But till the 6 months time window or 180 days, I want continuous feedback to improve it. That's why you buy time, right, to train the agent properly. Okay, so these are some of the scenarios, and this is called the production readiness pyramid. So first one is the foundations. Foundation is data foundations. That is important. Collecting and consolidating data from various sources. That is important. Second one is evaluations and quality of agent responses need to be evaluated. And you need to have enough guardrails to protect it. And the third one is the operability. So let's take you have an agent that requires hosting of a big model like 8 billion parameters or 9 billion parameters. Question is why? If you need to create a system that can answer the user's questions from or act as a tech support agent. Tech support agent, you can take a GPT-401 model, which is a transactional non-thinking model that can answer all of your questions. Why do you need a thinking model there? So from operability point of view, you have to evaluate what kind of model is needed for a specific agentic task versus taking the always frontier and the latest models. Don't consider the frontier and latest models and don't believe that big is better. Don't believe it. Because in real life, in production scenarios, it's very complex. Okay. Governance and compliance is also very important. As you already know, especially in enterprises, they work for different clients, different processes. How do you separate client one's data from client two's data? You have a product that multiple clients are using. How do you separate one's log from the other's log? How do you separate the context from client one to client two? How do you separate the memory from client one to client two? How do you build this kind of systems? Because your product is only one. Okay. And finally, the scale and the continuous improvement. So continuous improvement will come from your feedbacks, the feedback loop that I was talking about. And scale is something that you have to plan it. You need a cluster to operate behind the scene to support the agents. You can have single agent or a single system, but if you have multiple agents, then multiple API calls need to happen and you can host it on a cluster rather than a single machine, right? So to operate the agents, we have to operate it like product. Now, this is the new product. So now if you look at the industry today, we have services
we have products, we have tech-enabled services, or we can call it agentic-enabled services. Now, today, almost all the services are turning agentic-enabled. Why? Because wherever there is a decision-making or thinking or summarization or looking for information, we take the help of LLMs. The LLM is the core brain behind the agent's performance or behind the agent's decision-making process. That is why it's very important to think it as a product. Why product? Because when we launch a product, we look at the usages, we look at the feedbacks, we constantly improvise it. We constantly improve it for further versions. Version 1 of the agentic process, version 2, V3, V4, V5. Like the way we are seeing the LLMs are evolving over time, your agentic system should evolve over time. It's not just like one of the thing, I build it for a client, I shipped it to the client and done. No. You have to constantly monitor it. You are the creator of it. So you have to maintain, manage. Now let's take the model improves from, let's take today it is 5.5, tomorrow it is 5.6, 5.7. The prompt you have written when it was 4.1. Are you going to change your prompts also? Right? You have to evaluate your prompts once again. Because same prompt may or may not work in the latest versions. Maybe the same prompt has a different interpretation when the new models are coming up. So constantly you have to think, evaluate, improvise this agentic system. So we have to think it as a product. It's not a services that we are giving it to the clients. Fine? So the agents also need something from human beings. That means, let's take, I have implemented an agent and that gives vague answers or without like hallucinated answers, factually incorrect answers. So who is accountable for it? Am I accountable for it, or the agent I have to blame, or LLM I have to blame? Right? It's the human being who is involved in developing this agentic system, right? Responsible. So how do we ensure that? We are building a system or we are building a product that is capable enough to stop the prompt injections. Initially, when GPT launched, many people tried to contaminate the GPT thinking process by adding a lot of garbage or information. Like 2 months back, 3 months back, you have heard about Grok is being contaminated by users, right? So you have to stop that. Similarly, your agentic system is for the organization. That kind of guardrails are already there from the LLM side. But from agentic input point of view, if some of the users, they are intentionally injecting something which will make your agent think in different angles or different ways, you have to control that. So you need to have another agentic layer there or another LLM layer there to predict the intent. What is the intent of the user? Based on the intent, you straight away say that I cannot answer your question. You are asking wrong question, wrong window, right? So prompt injection is one of the area that we have to think about and build guardrails. Similarly, the permissions. The agents accumulate access across various systems, and we need to provide permissions, right? So if you are using Anthropic's Cowork or Code, sometimes you get a prompt instantly on your screen. It needs access to your download folder. We'll go ahead and just approve it. Wait, my download folder has my bank statements, my, let's take loan documents, my pay slips. Am I going to approve it? Think, right? Similarly, in an office scenario also, you have your pay slips, your increment letters. You are working on an agentic system that many users are using, and it tries to access my downloads folder and documents folder. Am I going to approve it? Yes, no. No, right? But when you are coding and you are in that zone, you will just quickly go ahead and approve it. Because you have to complete that entire process, right? So you have to think twice when you are approving something or access to a particular folder. Okay. Third one is the untraceable decisions. There are certain decisions you have interacted with LLMs long back, right? Maybe last 2 years. Do you know how much information the LLM knows about you? Ask a prompt, right?
intentionally or unintentionally, what do you know about me that I don't know? Ask LLMs. You'll get very surprising responses based on your usage patterns and whatever data you have inputted last 2 years. Okay. So now the traceability part here is you would definitely want to know that how this information is coming to the LLM. What did I do? What kind of data I have ingested here, or what kind of system I have given access to for, right? Similarly, and the final is the accountability gaps. Some people, they blame LLM, some people, they blame the agentic system, some people, they blame the prompts. But who wrote the prompts? Right? If you have written the prompts, fine. But if you have used LLMs to write the prompts for you, evaluate it, please. There are certain words, if you will write, you will never write it that way. So if you are using LLMs to write your prompts for you, spend time and read it properly. Okay, fine. The next one is the layered guardrails. As I said, the plurals are important because multiple guardrails you have to provide. Is your input? You need to have input filters. You have to look at the policy engine. You have to create your agent execution, the logs. What happens in this entire interaction between the tools, the memory systems, and the LLMs or the core reasoning layers, and the audit log. So there are 4 pillars which are very important: transparency, control over the agentic operations, accountability, and alignment. So what are the patterns from the front line? Today, we can start with a narrow prototype, expand by adding more tools, improvise it. Number 2, have human in the loop by default. Number 3, specialize the agents, orchestrate them. Specialized agents means document parser agent, summarizer agent, reading information from image or text agent. Keep it separate. Don't have a universal agent that will parse everything, because one agent may be good at parsing information from text. One agent may be good at parsing information from images. So have them separate agents. Fine. And treat evaluations as your production code. Make cost the first class metric. That means you have to save a lot of token cost, and you have to save a lot of your LLM cost. Okay. And these are the failure modes. And let's take it worked in the demo. Okay, fine. But why it's not working here? Endless prompt tuning loops. It did not work. Okay, let me change the prompt. Right? Okay. It provided a wrong answer. Okay, let me add a new sentence to the prompt. When you are going to freeze the prompts, you have to keep iterating the prompt. That's fine. You have to make the agent better. But in production, you can't just change the prompts, right? How many of you heard that? Okay, client is saying that you have put the agent in production, but can I change the prompt? I need a screen where I can see the prompts. But why? You have already approved it on the development stage or prototype stage. I have created everything. I have evaluated. It has gone through the testing process also. But finally, also in production, you want to see the prompts. Right? That means the scope has not been included in the beginning properly. Okay. So these are some of the failure modes. But the failure modes are not the place where we want to be. We have to find some solutions and move forward to the next step. And that should be the case. So the agents can be looked at as a product, as I said, because you have to build, maintain, operate in the long run as well, because it's solving a particular use case for somebody. Okay. So the key takeaway here is, beyond the testing scenario, you have to be ready to accept the unhappy path. We always show the happy path in the demos, right? You have to be prepared for unhappy path also, where the agent could go wrong. Add one statement. The LLMs, they have added a statement. It is generated by GPT. Please use with caution, right? But the agents that we are building and shipping it to the client, we don't have a disclaimer. Please add that disclaimer. This is generated by agentic process. Don't be so sure about your agents. Add a disclaimer, right? But I understand your client will say that if you are not confident, then how are you selling it? right? That would happen, but still you need to have that disclaimer because you are using the LLMs as the brain of the agent. If they are also having a disclaimer, then you need to have a disclaimer also on your agents. Okay. And operate agents as the products and definitely bake in the governance. So I have a quick prototype or a demo here, which is like it's a multi-agent system where it is operating as a, just one moment, please. Yeah. So this is a compliance reviewer agent, which looks at different data sources, your compliance clauses on various documents, and it has the human in the loop, and it processes the information. It highlights what is needed. So we need the Q3 2026 compliance review and highlight the important parts of it. I think it's not visible, right? Because of this reflection. So the left-hand side, if you look at, sorry. Yeah, it's fine. Can see it? Okay. So if you look at, these are the steps, the agentic steps. First one is identify the jurisdictions. You have different policies, different engines, different locations. So you have to look at, I'll just quickly replay it. You have to look at, identify the jurisdictions. The goal here is we need a Q3 2026 compliance review. I'll just pause it, just one moment. Quickly, I'll just explain the use case here. So the goal here is compliance review. We need Q3 2026 compliance review covering our new cross-border crypto custody service for US, for European Union, UK, and Singapore. Identify in-scope regulations, check our internal policies for the gaps, cross-reference any open audit findings, draft a memo, and priority high. This is the task. And these are the steps. So first we identify the jurisdictions, retrieve the regulations corresponding to different jurisdictions. These regulations are already being passed, chunked, and embedded, stored in a vector store. Check the internal policies. Again, via MCP server, check it with your Confluence documents for internal policies. Cross-reference the open cases, draft the compliance memo, and finally file and notify the owners. And this is the planning step of the agent where we are making an LLM call and we are decomposing this task into 6 subtasks. Finding out the jurisdictions are explicit. So this agent is going to resolve in-scope regulations from the security corpus and check for internal policy differences, pull the open audit cases, then draft the policies. This is making a tool call. There are 6 tool calls need to happen. So it is having one of the 6 here. The others are there in the background. Then the result, it looks at the jurisdictions and tells you that it is resolved. Then it is thinking mode and thinking 3 jurisdictions, 11 discrete regulatory instruments. Then again, it is making another tool call, the 3 of 6. The third tool call is happening. This is the policy engine. The policy engine comes from your open telemetry. And I have to replay this. Fine. So with this demo, what we can see, how the LLM is planning, what are the tool calls happening, vector search is happening, reasoning happening from LLM point of view, tool call happening via MCP server to connect to the Confluence documents and pull the relevant policies. It looks at various other tools and finally the LLM is drafting the response. And this is human in the loop where it is asking for approval. It waits for 15 seconds. Within 15 seconds, 10 to 15 seconds, if you are not approving, auto approved. And then it goes to the tool call once again, and finally it's done. Okay. So it's a multi-agent system, and this is how you have to design your multi-agent systems into production systems. So I would be happy to take up any questions if you have any. Thank you. Any questions? Yes, please.
Yes.
You mentioned about the tools, especially the observability tools. Tools in this industry. I'm just curious to understand. Tools like budget model, data model, models of certain disciplines, operations, infrastructure operations. I suppose these enterprise use agents and this.
I think I did a research on finding out because I wanted to build a ATC, agentic tower for various agentic calls. So that ATC for all orchestrated study you have to build it. But based on my finding, I couldn't find it. I did not wanted to build one in this area. I wanted to first check if someone is offering, then I can buy it. But I didn't get it. The exact operation here is like which agent is calling which other agent. And what happened? How many times wait time is there? Whether we get the response, we got the response or not. After that, what happened? So entire calling between various agents, it need to be mapped at an observability level at a higher level. So I couldn't find that. So then what we did is we put individual logs, then if there is a master log, then put an LLM agent on top of it to monitor all those logs and write down their interactions as a separate log. So while logs only you have to manage it. There is no single product today. Yeah.
Platform is a newest partner.
I heard, yes.
Because I didn't have to explore those things because it's especially great for this particular statement of this.
Sure, I'll explore that.
Yeah.
Blue bus, right? Blue bus. This is from LTM. Yes. I heard about it.
Yeah, hi sir.
Yes.
Good morning. I just wanted to know how the security and governance is handled in this agent. And also regarding the scaling, is the auto scaling enabled and how that basically did you enable the horizontal and vertical scaling both or enabled auto scaling? So how these two are taken care in this agent?
Actually, this is a very broad question that you have asked and multiple steps in answering this question.
Yeah, because even I build agents, so the biggest challenge for me is to set up the security and governance. Because an agent without proper security and governance and also guardrails is of no use.
Exactly.
So that is the biggest challenge according to me. So how to handle this and how did you handle in this particular agent? Just
Right.
curious to know.
Correct. So what happens like from governance point of view? First, you have to look at the agents. They have access to databases, tools, and probably the third-party APIs. Right? So these are the three things the agents have access to perform a particular task. You have the governance and the risk control. There are certain policies. Right? So you are monitoring the behavior of an agent in compliance with the documents, other policies. So you need to design this system. Like the agent should be having the information about what is approved, what is accepted, what is not accepted as per the policy. So you have to add a separate instruction as a guardrail to the agent that first think about the compliance policies of our organization before considering any output to the user. And that is a set of like 10, 15 lines, bullet points. You have to look for what is allowed, what is not. You have to look for approval flows. You have to look at escalation metrics. You have to look at there is a set of instructions. So you can have one set special as a compliance agent, which will monitor input as well as both output. Input when you are receiving from the user, first you check the policy. And if your compliance agent can directly say that the question you are asking is not compliant with that from my topic, I can answer this. So don't entertain that first. That is the first thing. Second thing is, your agent has performed the activities and it already drafted the response. Then I can call the compliance agent. The compliance agent should check that and say that, okay, the response that you are giving is not allowed. As per the policy. Drop it. Don't send it to them. And send a message that, okay, this is my escalation matrix, talk to your supervisor. This is not allowed. So you have to design. The scalability part of it. What you want to say. The agents are having a brain, which is the LLM. Right? The LLM have access to the data. You want to provide terabytes of data to LLM? No. That's where you need scalability. Right? So scalability is about handling volumes of data. That is one kind of scalability. The other scalability is basically concurrent users. I have 100 or 200 concurrent users. If I have hosted the event on a single machine, it is going to crash. That's why horizontal scalability will help you to have multiple replicas and you have a load balancer to read out the users to multiple instances. That is possible. But vertical scalability, I don't think that is needed. Database related scalability, I don't think that is needed in agentic operations. Any other question?
Yeah, hi, I'm Archana. So while you were explaining about the agent observability, that's something related to AWS CloudWatch, which does some tasks for us in terms of agent tracking and tool calling and all of that.
That is related to systems, like which MCP server you are calling, what's the IP, what's the port ID, what response you got, and logging those details. That is CloudWatch. Also, if you are getting 100 plus concurrent usage requests from different users, your machine is operating at 90%, 95%, it may go to crash and generate errors. That can handle the CloudWatch. But at a granular level, what prompt was being given, what response was being given, which agent has given the response, which agent has not given the response and skipped to the next step. This kind of detailed thing will not find in CloudWatch.
And also the demo that you shown, when you meant it's an agentic, so the action part of the agentic workflow was mostly about task delegation to agent.
Correct. So first one is taking the input documents or policies, extract the clauses. That is the job of the first agent. The second agent's role is and have those clauses check into internal documents. Okay. So you have to separate their roles, separate their activities by the agentic process.
That was all the action component.
Yeah, you
Yeah,
can say.
so
Due to the
I think we're running out of time. Can we?
yeah, I think
Last two.
last question.
Okay.
So one quick question on the agent works, like most of the multi-agent works put together within one virtual machine and very much scaling. That is bigger to whole agent. Again and again, right? Multi-agent. Because it's all put in one VM and all the agents are running in one VM. So if I go from the comparison of the microservices architecture, where the independent services can scale up and scale down, here I see the whole VM need to be scaled up or scaled down. So I just wanted to know, because most of the framework which I see are all dumped in kind of a tag within one single VM. I feel it's very constricting because I am not able to scale up one single agent at particular speed. So I want to get it.
See, it depends on the type of agent. So let's say you are building something called LN to SQL. From natural language, you are converting back to SQL query. You are filing the SQL query to the database to get the data. Now, if it's just a conversion of natural language to a SQL query, you don't have to scale it again. For the size, the VM size is not the problem there. The problem is concurrent users. If you have 100 concurrent users and everyone is asking LN to SQL, probably you can separate them by putting a load balancer and redirecting the traffic to some other machines. That you can do. But if you have a different kind of agent, let's say I have my entire customer database of like 2 terabytes of data, and the customer called me to process the refund or to check the status of the refund. I have to pull the entire data to do a query of this particular customer to figure out if the refund is processed or not processed. What is the status of it? If I have to find out that, and I have to load this entire data, right? Then I need a machine which is big enough to hold this entire data to do the search. That's one way. The other way is you send the query directly to the search in the database. And that's why you need to have the API contacts. This API is sending the customer's information to be searched there. And there is one more agent there in the database which performs the search and returns the response to me that this is the status or maybe records not there. Right? So different agents, they have different processes. Based on that, you can design your system architecture.
Somebody will be answering.
So while explaining, you said a human interaction should be there while agents taking while agent
Human approval.
human approval while agent was taking a critical decisions or like that. But while showing your demo, you said that it will auto approve within 15 seconds.
This is
That
for demo.
means, yeah, for demo, what is your intention behind it? Like,
I wanted to complete it within 90 seconds.
okay,
The demo.
yeah,
So I can make the agent sit here for next 20 years to get the approval. I have no problem. It's just a matter of changing the time.
yeah. But what is your view, like how it should be solved because you said it is not yet implemented, right? So,
Right. So you have one workflow where you need your manager's approval.
Yeah.
Right. So you will call your manager, okay, you have already got an email, can you please approve it?
Yeah.
And if your manager then vacuous, he has no access to the emails, then you want your agent to like stop there, or you have to proceed.
it need to be proceeded.
Need to be proceeded, right? Otherwise, you can just say that, hey, I need approval and it's not there, so close the request.
Yeah.
So the question here is, it's not about technical. It is doable. You can have endless time to wait. You can also skip that process and go to the next step, or just write a message. It's up to you how you design it. Yeah. Thank you.
You must also speak on what we cover in our Agentic AI course.
Yes. Yes, so we do have the hands-on Agentic AI course here. So it's 12 weekends on Sundays. So mostly between 9 to 11 or 9 to
9:30 to
11.
1.
9:30 to 1:30 we have the Agentic AI course. So we look at, if you look at the course structure, so we have everything here. So you can start with basic agents. You can start with agents only as LLM. So if you look at the broad structure, there are 3 different kinds of agents that you can make. One is agents with LLM, agents with LLM plus tools. Second one, agents with LLM tools and other APIs, third-party APIs. So there are 3 different segments. In multi-agent system, all those things that I have discussed here, somehow you have to implement it. Somehow you have to like write those codes, not like on your own, you can use LLMs to write the code, but you have to nudge the LLM to give this code to you. So you have to know what to ask. Right? So we covered almost all the multi-agent systems, different kinds, different prototypes. You should be able to build those kind of prototypes on your own, right? And you should be able to implement it on a single machine. You should be able to deploy it. You can deploy it on Databricks, you can deploy it on Azure, or you can deploy it on AWS as Lambda. So this is the entire course structure designed in such a way, starting from beginning, what is agent, to deploying the agents, the end-to-end part of it.